Hey everyone, we're gonna do the, um, what do they actually call this? Practice day one, practice problems for lesson 1 through 12. Yeah, okay, so in your Desmos account, it's called 7.6.01-12 practice. It's essentially, it's like review problems for lessons 1 through 12. So let's do these together. This lesson, you're mostly typing. It's asking you to write out the steps for solving these equations. And so most of our answers are going to be like subtract such and such from both sides of the equation, and then add such and such to both sides, or multiply, divide. Um, it's just putting what we know as like the ways to get from an equation to a solution into words. So number one, or 1.1 here, it says, explain how to go from the problem to the solution. Oh, I'm so mad at Desmos for calling an equation a problem. Equations are not problem. They shouldn't be thought of as problems. They're statements that this stuff over here on the left is the same number as this stuff over here on the right. And your solution is the number that makes that statement true. There's no problem here. Um, I almost want to borderline write Desmos an email about that. Anyways, all right, rant over. 5x minus 10 equals 25. That's our beginning equation, and we want to get to the solution x equals 7. Well, the first thing I would do is, so let's write first, add 10 to both the sides of the equation. I'll write equation this time, but later on I'm going to start shortening that to just EQ because I'm lazy. All right, and so if we did that, you would be left with 5x equals 15, right? The minus 10 would go away and 25 would get increased to 35. And so, let's write that out. So now we have 5x equals 35. All right, and then next, we would divide both sides of this equation by 5. That would change the 5x to just x, and 35 divided by 5 is 7, and so we would arrive at the solution, x equals 7. Simple as that. It's a two-step equation. It takes 2 steps to solve it. Add 10 to both sides, divide both sides by 5. And let's do the next one. All right, so here we have 5 times the quantity x minus 10. The quantity is a way to verbalize the fact that x minus 10 is in parentheses. All right, so it's a very similar equation, right? But it's a little different because we could distribute that 5 into the parentheses. That's one strategy for solving this. We could turn 5 times quantity x minus 10 into 5x minus 50. We're not going to do that though. Instead, we could start by dividing both sides of this equation by 5. What happens is this factor of 5 right here, since it's multiplying all the other things on its side of the equation by 5, when you divide that side of the equation by 5, well, you kind of wind up with like a 5 on top and 5 on bottom of a fraction, right? Because you can think of it as like, I'm dividing everything over here by 5. Well, a 5 on top and a 5 on bottom, they cancel out, they go away. And you're left with x minus 10 on that side of the equation. And on the right side, well, we took 25 and we divided it by 5, so we get 5. Now we just want to add that 10 to get it away from the x, right? That minus 10. So now add 5 to both sides of the EQ. And we're left with x equals 15. There it is. All right, let's do the next one. So this is similar again, but this one's a little tricky because it says 5 minus the quantity x minus 10. So we're supposed to subtract all those things in the parentheses. I like to do something here that mathematicians call distributing the negative. So I think of this minus x minus 10 as minus 1 times x minus 10 in parentheses, right? We're always allowed to multiply any number or quantity in our expressions or equations by 1 anytime we want, because multiplying by 1 doesn't change anything. So I can think of this as 1 times x minus 10, but it's got that minus sign in front of the 1, right? Well, if you're in my class, and I think Mr. Wong probably says something similar, anything that's a minus in your expressions or your equations, whatever, you're better off if you think of them as plus the negative version or the opposite version of whatever comes after the minus sign, right? And so I'm thinking of this as -1 right here in front of the parentheses. And I'm going to distribute this -1, people just say distribute the negative, to the two things in the parentheses, to that x right there at the front, and to that -10. Notice I'm saying -10 because it has that minus sign in front of it. And so what we get out of that when we do it, I'm going to type it over here because my writing's not very good, is you still have that 5 in the front. But that positive x inside the parentheses now becomes a negative x, which I can write as minus x because those are the same, right? But then that minus or -10 that was in the end of the parentheses, it gets flipped. Now it's a plus 10. So when you distribute the negative, basically what you're doing is just flipping everything that was in the parentheses. If it was positive, now it's negative. If it was negative, now it's positive. And it's still going to equal 25. Nothing changes on the other side of the equal sign. All right, and so now I think we should probably combine like terms before we start to solve. It's always a good idea to see how we have a 5 and a 10 on both sides of on the same side of the equation here. That 5 and that 10 can be added. We're allowed to do that, and we should. It just makes solving easier. So the 5 and the 10, they're both positive, so they make 15 minus x equals 25. Now we're, oops, that's supposed to be an equal sign. Now we're really ready to solve a two-step, well, yeah, I guess we will need 2 steps because we're gonna have a little weird step at the end of this one. So now I've got my actual first solution step. First, let's subtract 15 from both sides. So the 15 that's on the left goes away, right? Because it's a positive 15, we're taking 15 away from it. The 25 on the other side turns into 10. And what we're left with is, here's the big, like, important thing. Pay attention to this right now. If you're working on a different tab, open this, look. What we have is negative x equals 10. Because that in the step before, it said 15 minus x, I'm thinking of that as a negative x. And when I get rid of the 15, the fact that that x was negative doesn't change. Like, I got to make sure to carry that sign down. A very common mistake on this one would be for a student to miss that negative sign on their x and then say the answer is x equals 10. But in fact, negative x equals 10. So you got to think about that. Negative means opposite, right? So the opposite of x is 10. So that means that x should be negative 10. And one way we could show that is by multiplying both sides. Oh, I guess I should have said multiply, but whatever. Multiplying both sides by -1. When we do that, the negative x now becomes positive x, and the 10 now becomes -10, which is the solution we were looking for over here, right? X equals -10. All right, there we go. All right, here's another one. Here's a problem and its solution. Well, I guess this one actually kind of is a problem because they're giving us a word problem rather than an equation. So I'm not mad about this one. My best friend and I are the same age. Okay, so 2 people who are the same age. In 4 years, they'll still be the same age, right? Both people will get 4 years older, so they'll still be the same age. But our ages will add to 50. All right, so right now their ages don't add to 50, but when they both get 4 years older, then their ages will add to 50. We plan to celebrate big time, create a visual representation of this situation. Okay, so it looks to me down here that, first of all, whoever did this, they're using a variable, right? If you're gonna use a variable, you have to define it. So if we're talking about how to get from the top to the bottom, we gotta write the middle. Well, a step that should happen in the middle of this would be first define X as, so it looks to me here like X is supposed to represent their original age, right? In the tape diagram here, we have two quantities of X plus 4. Well, X, I think, is supposed to be their original age, and then they're adding 4 to that to show that both people are getting 4 years older. So let's define X as their original, I guess we could even say current age, right? Because it says, right, because the 4 years is supposed to be in the future. So I'm going to say their current age. And then I guess what we're supposed to do here is describe how to make this tape diagram, not like solve an equation, because the solution in this case is the tape diagram. So make 2 boxes of X plus 4, oops, right, that's what they have, 2 boxes with X plus 4 in them, to show the ages of the 2 people in 4 years, right? There's 2 people, they're both X years old, but we're gonna add 4 to both of their ages because they're both gonna get 4 years older in 4 years. And then put 50 across the top to represent the sum of their ages will be 50 4 years from now. So that's how we go from essentially the word problem to the solution in this case, which is the tape diagram. So if you want to go ahead and solve it, you can. And the answer is probably 21 if I had to guess, but I don't think that's what Desmos is looking for here. They want you to just show that you know how to make a tape diagram through description. All right, and so this one, it looks like it's the same question, but this time they want us to describe how did we go from the word problem to the equation. So it's very similar. Our answer is going to feel pretty similar, actually. So it looks like we're supposed to show maybe how either or works. How about this? This equation right here is essentially the same as the tape diagram we just described in the previous screen, because it's 2 times quantity X plus 4, and the tape diagram had 2 boxes of X plus 4. But this one, on the other hand, the one that I'm underlining, it's also a good equation for this problem, but it's a little bit different than the other one. So let's describe how to get this one. We don't have to write the fact that X represents the current age, because they actually put it in this one. So let's type it like this. We know each person is X years old. Right? We talked about that on the previous screen. X is going to represent their current age. So I'll say X years old now. There are 2 people, so we represent their total age, or maybe I should say the sum of their ages, but we'll say total age with 2x, right? 2 times their age, and that's what we have down here in this equation right there. Then we add 8 because in 4 years, both people will be 4 years older, which means a total of 8 years aging, right? They will have like aged a combined 8 years, 2 people both getting 4 years older. And then we're adding those things up and saying they equal 50 because the sum of their, let's say their new ages, like after they've grown 4 years, will be 50. I think that's a pretty good explanation of how you could go from this word problem to the second equation, the one that's underlined. What advice would you give to yourself or others when solving equations? There's lots of different things you could type here. What I would say is look at the operations being done to the variable. Decide what order PEMDAS would say to do those operations. Then use the opposite operations, right? So like if you have multiplication in your equation, you use division. In reverse GEMDAS, or PEMDAS, I said PEMDAS before, now I'm saying GEMDAS. Doesn't matter, they're the same thing. In reverse GEMDAS order to solve. Okay, so reverse order and opposite operations. That's like the whole basis of this equation solving algorithm that we're practicing. And reflect part 2. Name one strategy you found useful so far and explain why it was useful to you. I'm going to let you answer that on yourself. I'm sure you can come up with a strategy that's been useful to you. I don't need you to give you that answer. So, all right, I'm going to go ahead and end this. See you next time.